Hello everyone, I am Saloni Khobragade, currently pursuing Masters of Technology and Information Technology from International Institute of Professional Studies, DAVV, Indore. I welcome you all to my first ever YouTube video that is about Java threads, which was assigned and guided by Dr. Nitin Nagar Sir. So getting into the video, the key topics of today's discussion will be: first, the life cycle of the thread; second, the thread priorities; and third, Daemon threads. Listening to the word thread, the first thing that comes in our mind is, what is a thread? So the answer to that question is, a thread is a lightweight sub-process. It is the smallest independent unit of the program with a separate path of execution. Every Java program contains at least one thread. They are controlled and created by the java.lang.thread class. As now we know what a thread is, a thread too has a life cycle, like every living being. A thread life cycle has in total 5 states that are new, runnable, running, non-runnable, and terminated. A Java thread can only lie in one of these states at any point of time from its creation. Let's discuss these states of thread a little. The first state is new. When a thread is newly created, it begins its life cycle. It remains in the new state until the program starts the thread. It is also known as a born thread. The second state is runnable. The thread, once started, comes under the runnable state. The threads in this state are ready to run, but they are waiting for the resource allocation from the system. The thread stays in this state until it starts executing the task. The third state is running. The thread in this state starts executing by a start method. We can send back the thread from the running state to the runnable state using the yield method. The fourth state is non-runnable. A thread is in this state when it is temporarily inactive. That is, it is still alive, but is not eligible to run. It can be in waiting, sleeping, or blocked state. The fifth state is terminated. A runnable thread enters this state either when it's complete its assigned code or due to some unusual wrong event. Let us understand the life cycle of thread with an example. Let us consider that we want to listen a song on YouTube. So we created a new thread, that is, by searching the song on the search bar. Once the song we want to listen appears on the screen, we click on it to make it buffer to start the song, which means the thread went to the runnable state. Completing the buffering of the song starts to run smoothly, making the thread to be in the running state. As the song runs, it soon completes, making the thread to be terminated. But sometimes we pause our song due to some events which makes the thread comes into a non-runnable state. Or sometimes we just close the YouTube tab, terminating the song before it completes. Though we can notice that searching a song in YouTube too is an individual example of life cycle of a thread, but getting a clear version, we can consider this as an example. Moving to the next topic we came across is the thread priorities. In our lives, we all have some people, things, which have our topmost or least priority. Similarly to us, the threads too have the priorities assigned to them. That helps the thread scheduler to determine the order of the thread is scheduled. The thread with high priority will usually run before and more frequently than the lower priority threads. Every thread created in Java Virtual Machine is assigned with a priority. The priority ranges from numerical 1 to 10. 1 is called the minimum priority, 10 is called the maximum, while 5 is the normal priority. The default priority of any thread is 5. The constants in the thread class for the priority are min underscore priority for 1, non underscore priority for 5, and max underscore priority for 10. Based on these priority assigned to the thread scheduler determines how the thread will be scheduled. It determines which thread gets to run first. We can manually set the thread priorities of the thread by using the set priority method and read the priority using the get priority method. So let's look to some examples to set and get the priority of the thread. Here, in this example, we set the thread priority by the Java constants. So we created a class of thread priority which extends the thread class. We create a run method which prints out the thread name of the currently running thread and the priority of the thread. We create the main method where we create 3 new threads named as M1, M2 and M3. We set the priority of these threads using the constants and set priority method. M1 as minimum, M2 as maximum and M3 as normal. After setting the priorities, we start these threads using the start method. As we run the class, the output is received. We received the name of the running state that is currently running, and then after the threads, we receive the priorities of the thread respectively. Let's look at one more example to set the priority of the threads by user-defined values. We create a new class that extends the thread class. We make a run method that prints out the thread is running. Then in the main method, we create 2 threads that are T1 and T2. We set the priority of T1 4 and T2 7 by the set priority method. Using the println method, we print out the priority of the 2 threads by using the get priority method. The output we get of the priority of the threads are T1 and T2 respectively. Coming to the next topic, in Java, we have mostly 2 types of thread. First is the user thread. It is also known as a high priority thread. Second one is the Daemon thread. It is also known as a low priority thread. Discussing about Daemon thread. Daemon threads are called background thread. They work in the background to provide the service for the other threads. These threads only run when the other threads are available or running. If not, the JVM will shut down all the daemon threads. The main thread and all its child threads are non-daemon threads. But if we want, we can make the user-defined thread as a daemon thread by using the setDaemon method. Daemon threads are mostly used in garbage collection, releasing memory of unused objects, and removing unwanted entries from the cache. As we saw before, there are 2 types of threads, which are the user threads and daemon threads. Let's see the key differences between these 2 threads. The user threads are designed to do some specific task, whereas the daemon threads are designed to support the user threads. User threads are foreground threads, while the daemon threads work in the background. The user thread's life is independent. while the daemon thread's life depends on the user thread. The JVM waits for the user threads to finish its task. It never exits until all the user threads finish their work, while the JVM doesn't wait for the daemon thread to complete its work. Once the user thread completes their work, the JVM will exit. The JVM will not force the user thread to terminate, while the daemon threads are forced to be terminated once the user thread finishes their work. User threads are created by the application, while mostly the daemon threads are created by JVM. Now let's see an example to create a daemon thread. To create a daemon thread, we create a new class. In the main method, we create an runnable action for the daemon thread. We create a run method where we put a while condition true, which will print out the output. Then we create the daemon thread by the setDaemon method to be true, and then start the daemon thread, setting the time of its sleep. After that, we complete the code. As we run the code, the console prints out the output till the time the daemon thread is set to sleep, terminating the thread. Let's see one more example. As we created a daemon thread in the previous example, now let's check whether the threads are a daemon thread or a user thread. For this, we created a new daemon class which extends the Java thread class. We made the run method to check whether thread is a daemon or not, and print it out. Now in the main method, we create 3 daemon objects, setting the first and the third threads to be setDaemon true, and then starting the threads. As we run the program, the console prints out that the first and the third threads are daemon threads, while the second one is a user thread, completing the code to run successfully.